The American Shotcrete Association sponsored a mega demo at the 2005 World of Concrete that illustrated the versatility of the shotcrete process. The mega demo started with a demonstration of the use of the dry shotcrete process for concrete repair projects.
This simulates a typical structure, a bridge pier, abutment, a wall, a column, anything that you might see. If you just turn and look around you, you see concrete all over Las Vegas. And some of that deteriorates. In the northeast corner of the country, the northwest, some of the older parts of the U.S., you've got carbonates and freeze-thaw cycles and salt and just plain age, poor mix design, all those things contribute to deterioration of structures. And in many parts of the country, the gunite process, still commonly called that in the field, although officially dry shotcrete, is one of the preferred methods for this sort of what we call dental work. The dry process, which is the original shotcrete process, provides for a dampened granular material, sand and cement, conveyed in an airstream to the nozzle. At the point of placement, the nozzle, at the end of the nozzle and the point of placement, the nozzleman is adding the water desired to give him the proper consistency of the material. And by test, the water-cement ratio at the point of impact on the substrate is about 0.4. And you'll see when the finishing process starts, there's still plenty of plasticity there, even though the term dry might connote that it's different than wet concrete. When shotcrete strikes the surface, whether it comes from a wet hose or a dry hose, the water-cement ratio and consistency will be about the same. The nozzlemen here today, most of the crew members are all ASA members, certified nozzlemen, which is one of the primary functions of the Shotcrete Association, is to act as the primary sponsor, local sponsoring group for ACI nozzleman certification. The program has been very successful in improving the quality of shotcrete around the country, we're happy to say. In fact, there are European and Asian groups that have also requested support from us to develop a certification program there. Shotcrete is pneumatically applied concrete. So what we're doing here is no different than what's being done out on the other 30 acres of flat work and walls. It's still concrete placement. The technology, in my mind, is a little ways toward the higher end of the spectrum. You've got very, very critical gradation to properly impinge the substrate. You've got the skill requirements of the nozzleman, but most of you who flew here didn't fly with an untrained pilot. So training a nozzleman and providing the certification program that assures their experience will guarantee a proper application and a good repair. The material that's being supplied to Alain is coming from a dry rotary gun being fed by a pre-dampener. Pre-dampening is an absolute must. The original gunite process, as patented, specified that the sand content moisture should be 4 to 6%, or 3 to 6% is sufficient. And this not only controls the dust, but it actually allows contact between the cement and moisture to start a prehydration, which helps develop the crystal of the cement particle more fully before it's placed on the surface. So the period of time between contact with water till it discharges at the nozzle is probably 2 to 5 minutes in most application cases.
The wet process was used to demonstrate new construction work.
You'll notice at the end of this wall a lot of congestion in the steel. This is typical of a seismic retrofit that you might find out on the West Coast. One of the important crew members in this application is the blowpipe man that you see following Casey around. And he's going to ensure that no rebound and no poor material gets incorporated behind the steel. The nozzle will go right inside the first layer as you see him placing it now, so that he's sure that the concrete is being wrapped around the back layer of rebar. Blowpipe man is a key partner. This is a real team effort between these two folks. They can probably interchange switching nozzle and blowpipe with each other as well. We're going to take this wall up in one lift, move across. This is where technique becomes very, very important. This concrete is coming out of this truck on this side through a reed pump. Here, as opposed to the dry side, the energy that's conveying the material through the hose is the piston action of a hydraulic pump. Most of you are familiar with that. It's the same process as you're familiar with for flat work or wall placing, any other structural placement. One of the most important things to point out on the concrete side is the fact that the hoses you see all these guys holding are either 1.5 or 2-inch hoses. That means that the aggregate particle size is a maximum of 3/8. And when you mix concrete with a small aggregate such as 3/8 gravel, your surface area coverage goes up, so your cement content goes up. When we start cutting this wall to grade over here, you'll see it begin to take shape. It's actually a pretty fancy wall. It's got a chamfer strip up at the top, grades cut to the angles and corners, thickness control is right on the money. We got some fancy tools now to cut our grades. Are we going to replace the cutting rod, Mark? Here you can see a mechanized cutting tool. You can cut it to grade. This is interesting. When they get these two walls stabilized here, we'll have them go down and start finishing on the other end as well. A lot of skill and a lot of love for concrete. That's what keeps these guys going out here. And I guess that's what's important to all of you in the audience. Now you see Casey doing the top lift, and Ruben is watching over him with a blowpipe to keep it cleaned out. And once that's shot up, we'll trim it, finish it to a surface. See Ruben cutting to grade now. You can just see the evidence of the wire about 2 feet up at the bottom and 1 across the top. That'll be a square wall. When it's finished, you won't be able to tell that it wasn't formed and poured. The difference will be that you don't have to wait a couple of days to strip the form. There goes Casey back inside that column. If you'll note now, here, skill really comes into play here, and if you watch to get the back side of it, back behind the, wrapping the back 2 corners of this form, he puts the nozzle right inside the steel. The velocity and the plasticity of the material allows it to be flowed around those bars. So you're going to have good encapsulation, and there won't be any voids in there. We're working out of a mobile mixer back here from Cement Tech, going through a Reed bowl type gun. Very productive, very common in the pool business.
The shotcrete process is also used extensively in the construction of decorative landscape structures.
All right, this wall right here is all set up with line and grade wires. Again, like we saw down there, a shooting wire or piano wire pulled very taut is used to cut the straight edge. And we'll have finishing going on both ends, so those of you interested in the fact that shotcrete can be finished to look just like the original structure, whether it was formed with a shiny surface, plastic coated, hand troweled, floated, it doesn't matter, it's still concrete. The waterfall display that you see was framed up with a combination of rebar and some of the stay-form material that you see here, and also what you see lining the tunnel. It was shaped by the guys that are doing the carving and then shot up to a structural position. When you look at the decorative concrete up here on this part of the display, and in recent years, you'll be driving on various highways, particularly in the mountainous areas and also in Arizona, where you'll drive past a carved, natural-looking rock surface on what used to be a typical landslide area or a slope. However, before the decorative concrete goes in, a tieback system has to be created. When we get finished and you can walk down here, you might note some of the detail in the rock carving here. You talk to George or you talk to David and you ask them what kind of a rock do you want, they'll carve anything. Sandstone, limestone, granite, marble. Make it look like the real thing. Okay, we're going to make a marble cake in the pool. We're going to mix wet and dry, and I don't think tomorrow a core would tell you the difference. Now you begin to see some of the carving techniques come out on both these projects. David over here and George here. Essentially, the concrete in this truck is asleep. When the hydration control admixture was put in at the batch plant, the life of the concrete was stopped for the time being. So it can sit here for 4 or 5 hours and nothing will change in it. It's also a temperature control. Now, what we're shooting here and what we're going to shoot in the tunnel, we have an accelerating admixture line going into the nozzle. So that neutralizes or cancels the effects of the stabilizing admixture. So once it goes through the nozzle and it's treated with the accelerator, concrete will go to initial set fairly quickly. The wall over here that's holding Janice up was actually a form with the pattern that you see facing you on it. The form was set up along this line. We put a little bit of a radius in it and then shot it from the back and stripped it about 12 hours after it was shot. So that's just another aspect of the versatility of shotcrete and the artistic or architectural aspects that you can get in a concrete finish today.
Another application for the shotcrete process is the reinforcement of mines, tunnels, and other underground work.
On major projects such as a tunnel, we can handle more volume than a man is really capable of. So the mechanical, I don't like the word robotic because that kind of indicates it'll be automatically good concrete. The fact is, if you don't know how to use it properly, it'll make a bigger mess faster. All right, Jason's going to do a little typical underground work in the tunnel. Mining and tunnel construction is still on a smaller scale done by hand. Show that technique, and you can see already when you get above that 4-foot level, it becomes really tough work for the nozzleman. So we'll kick in the mechanical nozzleman here in a little bit and finish up the rest of this tunnel. And we've just taken the wet hose that Jason shot this corner of the slope and the wall of the tunnel with and hooked it up to the mechanical man. And this is a guy we can put twice as much material through and he'll never get tired. So what Greg is doing is just transferring the accelerator line over to the Aruga. This controls from a very sophisticated dosing and metering system the quantity of accelerator that goes in at the nozzle to the mix. We're using a 3% dose here, 3 to 4% dose. And if you change the stroke on the pump to increase or decrease volume, the volume of accelerator is also matched accordingly. For overhead applications, this is a must. There are other advantages with a mechanically held nozzle too. You can turn the air velocity up beyond what a man can really handle well. And that separates the sausage. What we're doing here that's different than dry. In the dry process, you're metering granular material into a moving airstream, 300 or 400 feet per second. And it impacts the surface at that same velocity. The oscillation that you see in the nozzle here is just to spread the material out in a more controllable manner. Otherwise, you'd build up too much material in one spot. We'd have bumps all over the wall. Now, that oscillation is an automatic function. The rest of it is just an Nintendo skill, hand coordination. Normally in a tunnel it's constructed in this manner. These are called lattice girders, and this lattice girder is a typical support in a subway system. In fact, this dimension of these lattice girders is a standard single-track subway system that you might find in New York, Washington, San Francisco, any of the major cities in the country which have a transit system. And after the ground is excavated, depending on the type of geology and the initial support component, which could be a rock bolt system, the lattice girders are stood and then shotcrete is applied for a primary support component. The lattice girder has to be fully encapsulated. It's reinforcement, just like the bars you saw down in Casey's wall. And that takes high velocity and a good flowable material. At the same point in time, as we're working up the vertical side and then overhead, the accelerator will react with the cementitious component in the concrete and cause it to approach initial set in a matter of a couple of minutes. A short period of workability, so there's plenty of plastic flow around the girder, and then it'll set.
Whether wet or dry, shotcrete is a viable alternative to the conventional practice of pouring concrete into forms. It can be impacted onto any type or shape of surface, including vertical or overhead areas. It forms an excellent bond with the substrate materials and can be given a variety of surface finishes. For more information about the versatility and quality of the shotcrete process, contact the American Shotcrete Association.